We should do a couple of examples about exponential functions first. So let's just do another example where we're considering this one. Okay, now we know that it's an exponential function because the x value right there is an exponent. And so that immediately tells us that this is going to be an exponential function. Okay, so the first thing we should probably do is fill out this table. Now, if you have a graphing calculator, something that looks like this, I have this app here, right? If you have a graphing calculator, what you could do is you can go to your y equals and clear out everything that you have there, and you could just go ahead and just enter this. So 3 to the, that means that I'm raising something to a power, and this is our x right there. And then you can just go to second and graph. Okay, the reason why is because table is in the color blue. So we click on well, on your calculator, this button would be blue, and you'll see that it comes up with a table. Okay, so here are all of our inputs, our x's, and these will be our outputs. Okay, now if you don't have a calculator, that's perfectly fine. We can still do this on the side. So what I'm going to do is I'm going to go ahead and just write this over here. F of x is equal to 3 to the x. All right, and we'll just start filling out a couple of values, but we're going to start off right here at 0, work our way down, and then we'll come back up and do this piece. So f of 0, okay, now every time that we're dealing with an x, in this case we're just saying replace it with 0. So we want to know what is our output, the answer we get at the end, if we were to drop in a 0. So we get 3 to the 0 power. And if you remember from the previous video, anything to the 0th power is 1, anything. So we're going to go ahead and just put a 1 right here, okay? All right. What about now f of 1? Okay, so now we're no longer dealing with this piece. We're still using the same function here in yellow. Instead of an x, I'm placing a 1 there. So over here, I'm going to replace this with a 1. And so now we get 3 to the 1st power. Okay, so that's just going to be 3, and we'll write a 3 down here. All right, same exact thing now moving forward for f of 2. We're just going to replace the x with a 2. So now it becomes 3 to the 2nd power, and this is also just means that we're just going to write the number 3 twice and then multiply those two, and we're going to get a 9. All right, and what do you think f of 3 would be? That's just going to be 3 to the 3rd power, which is 3 times 3 times 3, giving us 27. The only more challenging pieces come here. So for the first thing is, if you have, and I'm just going to go ahead and just write this function out again over here. Okay, if we're throwing in a negative, all right, the rule, or the way that I do it as well, is I actually put this over 1. Okay, because we want to have a positive here, all right? And what we're going to do is we're going to flip this. Now, we're going to literally flip this entire thing. 1 over 3 to the positive 1st power. So here it's negative, all right? And when we flip it, it becomes positive, making it 1 over 3 to the 1st. But 3 to the 1st, we already know from this piece over here is just 3. So this becomes 1/3, okay? Same exact thing now for a negative 2. This becomes 3 to the negative 2. When you flip it, it becomes 1 over 3 to the positive 2, which is just 1 over 3 times 3, which is 9, making it 1/9. Okay, so 1/9 is a very, very, very small number, much less so than it's a tiny number that's actually going to be between 0 and 1. So looking at this now, this function here, what do you think the base would be? Okay, now just try to see if you remember that. What I will do is I will actually write out what the general formula is, and that was a times b to the x. All right, so b would be your base, and our base here would be right there, a 3. Okay, what do you think the initial value is? Okay, so that's usually just the a. The a would be the initial value. Notice that there is no number here, okay? But another way to think about that is the initial value is the y value when x is 0. Now, given that we have this table here, or we can just plug it in here, we can go to where our 0 is when x is 0. This is our x's, this is our y's. And when x is 0, our output is 1. So in this case, our initial value is going to be 1. Okay. If we were to go ahead and just graph this now, let's see what we have here. So we have 0, 1, same as last time. Okay. 1, 3, 2, 9, okay, and 3, 27. So where's that going to be? That's probably going to be like up here or something like that, right? Then we have -1, 1/3. So 1/3 is, imagine splitting this one box up into 3 pieces. It's very small, okay? -2, 1/9 is so close to 0 you can barely even know it's there. And if you were to go ahead and do this, this is actually becoming a very, very, very steep curve all the way to the top there. Okay, and this goes on super close, but never passing. This is actually not even I'm not even doing this justice right now, right? It's so close to the x-axis there. Okay, but it's actually not touching or crossing it, even though it looks like it is for my drawing because I can't draw, but that's what it is there. All right, and so this would be an exponential function right here. Our domain is how far to the right and left. Okay, so how far, if you're going to go all the way to the left, okay, how far is the graph going all the way to the left, and then how far is it going all the way to the right? Don't worry about the up and down. Just think about if you're walking over, okay, on both sides, how far can you go? So going this way, yeah, you can go pretty far. It goes all the way to -infinity. And then it actually, when you're going this way, I know it looks like it cuts off here, but it actually really doesn't. It actually keeps on going up and up and up and up and up, and you can actually move all the way to the right infinity times. All right, and then for our range, I don't remember what that is now. The range, those are the y values. So what's the lowest? The lowest that this graph goes, and that it goes all over here. It comes right down here, and it never ever passes this x-axis or the y equals 0. So we're going to go ahead and say that the lowest is 0. And how high does this thing go? Right? So imagine it's a roller coaster. How high does it go? It goes shoots all the way up to positive infinity. Right? So those are the pieces that, or the elements that make up an exponential function. These are the two main pieces, okay, that make up an exponential function. All right. Let me see if we have time for one more thing. All right, this is really good. So for exponential and linear, now notice the placement of the x's. Okay, see how in this one, this is an exponent, and in this one, it's literally right next to the number 5. So these, although they may look very similar, are actually very different. This is known as an exponential. Okay, and this is linear. And with an exponential, we're going to be multiplying, okay, by, in this case, I'm going to say by the base, okay, and the base in this case is 5 each time, or every time that we're going, if the x's are going up by a certain amount, we're multiplying by 5 proportionally each time. Here, for linear, we're going to be adding 5 each time. Okay, so here, if we in this first graph, this is our x's, these are our y's, our x's and our y's. Let's start first with the linears, because I feel like we've done that a lot. So let's see, if you're doing this piece, you're just substituting every x here. So for the first one, 5 times -2 would give you -10. Then 5 times -1 would be -5. Okay, if I'm substituting a 0 into this x, 5 times 0 is 0. This would then be 5 times 1, which is 5. 5 times 2, I think you're getting it now from there, 10. 5 times 3, and we get 15. Right? So I'm going to go ahead and just erase this little piece right there. We don't need that anymore. Well, not all that. We don't want to delete all of that. Okay, and then on top here now, okay, let's go ahead and just substitute this. So I always like to start at the 0. This would be 5 to the 0th, which is, remember, anything raised to the 0th power is going to be 1. 5 to the first power is just 5. 5 to the second, that's 5 times itself, 25. Then 5 to the third, that's 5 times 5, 25. And 25 times 5 again, that's 125. Right? And then these last two ones a little bit more challenging. 5 to the negative first, which we can actually do that here. 5 to the negative first. Whenever you have a negative exponent, we're going to go ahead and just put this over 1. Okay? Then we're going to flip it. And as you're flipping it, this exponent will become positive. So 5 to the first was just 5. So this would be 1 over 5. Okay? Notice that it's literally kind of like the opposite. Let me see if I can do this. See how this is a negative 1 and this was a positive 1? It's kind of like the reciprocal of these. Okay, actually, it's not kind of. It is the reciprocal. So then 5 to the negative 2, I'm going to go ahead and flip this, right? So if I put this over 1 and I just flip it, okay, this becomes 5 to the positive 2, which is 25, so 1 over 25. All right, and graphing this, you're really going to see the difference. Let's see, 0 comma 1, right, 1 comma 5, and then 2 comma 25. That's like all the way over here already. You can't even get to 3 comma 125 because this graph only goes up to 10. And negative 1 here, right? And so what you have now is a curve. Okay, watch this curve. Okay, this is how you know it's exponential right here. It's this curve that it always looks like this. And then down here you have 1 comma, sorry, what is it, 0 0, 1 comma 5, 2 comma 10, negative 1, negative 5. All we're doing is just graphing. I can barely even see this on my screen. Bam, right? And you're gonna have a line that looks like this. I think I actually have a line maker right here. Okay, so let's go ahead and just make this line. It looks like that. All right, so you can see a very clear difference. Right, linear literally comes from the word line, or I should say line is really the root word of linear, and exponential comes with a curve. The curve usually always looks like this for the most part if it's going to be increasing in a positive direction. All right, and which one's better? It kind of depends on the situation, but you can see though we used the exact same x values, right? So negative 2, negative 1, 0, 1, 2, 3, negative 2, negative 1, 0, 1, 2, 3. We used the exact same piece here, 5. Okay, this was the base here, this was the slope here, but look at the y values. Okay, which ones increased the most? Here we made it all the way up to 125. Here we only made it up to 15. So an exponential will be increasing much faster for the most of the time. Which is increasing much faster than linear. Okay, so exponential is definitely the way to go if you want to cover a huge distance in just a very small amount of time. Okay.